Hey everyone, back here. Great. I think today is going to be a Tuesday, I believe, when I post this. Work on simplifying factors. We did some greatest common divisors yesterday. That's going to come in handy today. It's going to be a math-tastic day. That's all I got to say. All right, so we're diving into simplifying factors. Try to keep this one a little bit shorter than yesterday. Shouldn't be too bad. Our first thing is talking about equivalent fractions. This is something that you've learned before. Equivalent fractions are fractions that describe the same parts of a whole. So we know that 3/4 is the same thing as 9/12. We can simplify them to be the same. Equivalent fractions are anything that is equivalent to one another. You can find them by multiplying or dividing the fraction by a number on top and bottom. So right here, to make 3/4 into 12 or 9/12, multiply the top by 3, multiply the bottom by 3, comes 9/12. We could do that again. I could multiply that by 2 and make another equivalent fraction. That would be 18 over 24. Those are still equal to each other. They mean the same thing. Let's try to find two fractions equivalent to 4/12. So there's ways that we can do this. We can either simplify or we can make them bigger. We'll do one of each for this one. I know if I want to, I could either multiply or divide these. I'm going to start by multiplying them each by, let's just do 3. Multiply the top by 3, we get 12. Multiply the bottom by 3, we get 36. That would be an equivalent fraction to 4/12. Another way we can do it, 4/12. Let's find another one. I want to divide by 4. This is actually going to be our simplest form. We'll talk about that in a second. That puts 1 on top. That puts 3 on the bottom. 1/3 is another equivalent fraction to 4/12. I think this is something that you've seen before. This is something you know before. We'll give one more example here. Finding two equivalent fractions to 14. So you can either make it a simpler fraction or a more complex fraction. Let's start by making this one a simpler. I'm just going to divide it all by 2. I see that they can both be divided by 2, so I'm going to make it 7/10. That's going to be one of mine. Another way I could do this, 14 over 20. If I want to, let's multiply each side by, let's just do 2. Multiply by 2. It's going to be another equivalent fraction, 28 over 40. All equivalent fractions to 14 over 20. They look different. They mean the same thing. Those are our equivalent fractions. You can find them by multiplying or dividing the fraction by the same number on top and bottom. There are an infinite number of equivalent fractions. I can multiply this by 2, 3, 4, 5, 6, 7, 8, all the way up to infinity. There's going to be a different fraction that'll work for all of that. All right, on to simplest form. This is the smallest form of a fraction. We did a couple of them up here. 1/3 was an example of one. It's when the two numbers have no common factors anymore. They get to the point where there is nothing that they can be divided into a smaller. They have no common factors. I put an example on here. We started with 50 over 100. Simplify that, 25 over 50. Divide each side by 2. I then divided it by 5 because I could see they both could be divided by 5. Got 5 over 10. From there, I divided them by 5 again and got 1/2. Those couldn't be divided any further. That was my simplest form. What we're really doing here is we're finding the greatest common divisor. It lets you know what to divide by. If you find the greatest common divisor, you can do this in one step. I will show you how that's done right here. We have the example 8/12. I already got the answer over here for you. I wanted you to have an example. But I broke these into trees. I did 8, broke it into 2 and 4. 2 times 4 is 8. Prime number with 2. 4 times 4 is 2 times 2. This is the same as 2 to the 3rd power. Over here, I had 12. I broke that into 3 and 4. Broke that 4 into 2 and 2. Made that 2 squared. I had 2 2's times 3. From there, I found the common divisors. 2, they both had a 2 squared in them. This one had 2 to the 3rd. Took 2 of those out. 2 squared is the same as 4. So 4 is our greatest common divisor. What we do with that is we take it up here and we plug it in. We divide each by 4, and that is how we get our simplest form. We start with those trees, find the greatest common divisor, then divide the top and bottom both by that. there's going to be some tips and tricks that are going to help you make this a little easier for you. But this is how we're going to start with this. So we got 6 divided by 8. So what we're going to do is make the simplest form. I know you can probably figure this one out in your head, but I'm going to do my trees just so you get the practice. This becomes 3 and 2, both prime. This becomes 4 and 2, and 2 and 2. So 6 is 2 times 3. That's the prime factorization. Right here we got 2 to the third. That's our prime factorization. What do they have in common? They both have a 2. So 2 is our greatest common divisor. So we can divide each by 2 to get 3 over 4. That's our simplest form. We plug this 2 after we found the greatest common divisor, divide it by each. That's our simplest form. Do it again here with 9/12. We got 9, we got 12. 9 is going to be 3 and 3, both prime. 12 is going to be 3 and 4. 4 breaks up into 2 and 2. Here we've got 3 squared. Here we've got 2 squared times 3. What do they have in common? They both share 1 3. 3 is the greatest common divisor. Divide each by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. We got 3/4, our answer once again. We found that greatest common divisor. We used that to divide each. A little bigger one here. Let's do it. We're crushing this right now. 28 and 35. I'm going to do 28 as 14 and 2. I always like to try to break mine into 2 right away if I can. 14 becomes 7 and 2, both prime. 35, let's do 5 and 7. Done. Done. Okay, what do they have in common? This one would be 2 squared times 7. This one would be 5 times 7. I'm looking for common. They both have a 7, I see. 7 is our greatest common divisor. Divide each by 7. Gives us 4 over 5. That's our simplest form. Start with those trees, break it down, find those greatest common divisors. If you missed the lesson yesterday, go make sure you watch that. Otherwise, this one might not make sense to you. Use that greatest common divisor. Toss it in up here. Easy peasy. Okay, here comes the challenge. We're bringing the variables. Simplifying with variables. I think this is easier. Here's what we can do. The first step, separate the problem. Second step, cancel out everything that has matching terms. Check it out. Number 1, separate this problem. What that means that they want us to do is go y over x times y. I separated it. Oh, look at that. I'm so good at math. Now, we cancel out everything that has a matching term. Let's do it. I want to use my red marker for this, actually. That sounds fun. Look at this. Cancel out this. Cancel out this. They match each other. They both have a y. Cancel them out. We have to make sure. Leave a 1 when you cancel. We cancel these out. We leave a 1 on top. We leave an x on bottom. We leave that 1 on top. This doesn't become 0 on top. It becomes 1 on top. That is important right here. You cancel out the y on each. That was what they shared. That was their common divisor. It was easy to see for us. Crushed it. On to the next one. They give us b divided by a times b times c. We're going to start by splitting that up, breaking it down. Make that b, a times b times c. What do they have in common? They both share a b. Pull out that red marker, cross that out, cross that out. Wherever we cross out, we have to leave behind a 1 in its place. So we're going to leave a 1 on top times a over c. That is our simplest form. Up here, this is our simplest form. We found they're similar divisors, their greatest common divisor. Cancel those out. Okay, now we're throwing some numbers in there. It's going to be okay. It's going to be okay. First things first, we have to find the common divisors of these numbers. 3. I'm going to pull it out. I'm going to make a tree out of these numbers. This one would just be 3. 3 is already a prime number, so we're done. 12 is going to be 3 and 4. 2, 2, prime, prime, prime. This is 3. This is 2 squared times 3. What do they have in common? They both share this 3. That'll be important later. Okay, so we're going to break this up to be 3 times a times, watch what I do here, we have b squared. I'm going to break this up to become b times b. That's the same thing. We know that. We were learning that last week. On the bottom, I'm going to use these prime numbers that I had. I'm going to use what I broke this up into. 3 times 2 times 2. I'm going to change this to 2 squared times 3 times a times c. You might be thinking, holy moly, Mr. Aarons, why'd you just do that? Look what I did. I broke it up into those prime numbers. 12 we decided was 3 times 4. 2 times 2. All I did was make it 2 squared times 3. I used that in place of 12. I split this up. This is how we're going to get this into the simplest form. It's all coming together. It's all tying together right now. Now we cancel. We find what they have in common. Oh, they both have a 3. Let's cancel those out. Oh, they both have an A. Let's cancel those out. Anything else in common? Nope. 2 b's are left on top. That's the same as b squared. On bottom, we have 2 squared left behind and a c. We are done. That is the simplest form. I know it took some time. Take some steps. Stuff we know, stuff we can do. On to the next. Last problem here. We got 24 and 8. Let's start by finding those prime factorizations. Bam, bam. 24, let's make it 6 and 3. Let's make that 2 and 3. Boom, boom, boom. Over here, let's make this 8, 4, and 2. Make that a 2 and 2. Boom, boom, boom. This one writes out as 2 times 3 squared. This one writes out as 2 to the third. That's how we're going to plug them in here. So on the top, I got 2 times 3 squared times, I should change these little dots, times x times x. I broke that x squared. That x squared became a x times y. All over 8 is the same as this right here. 2 to the third times x times y. Time for the magic cancel out pen here. Let's cancel some stuff out. We've got 1 y on top. We got 1 y on bottom. We got 1 x on top. We got 1 x on bottom. Uh-oh. It's a little tricky. We got 1 2 on bottom, but we got 3 2's on, or we got 1 2 on top, but 3 2's on the bottom. Here's what we're going to do. We're going to cancel this out and change it into a 2. We took off one of those 2's, and we're taking out that 2 as well. See what I did there? There was a 2 right here. Right down here it was the same as 2 times 2 times 2. If you want to write yours out like that, you're more than welcome to. We could have wrote this out on the bottom as 2 times 2 times 2 times x times y. These are the same thing. I'm going to clean this all up now. On the top, we leave behind 3 squared x. On the bottom, we are just left behind with 2 squared. There is our simplest form of this problem. We're thinking about canceling out there. I know this can be tricky. I know this is not easy, but I know that you can handle this. Take your time. Reach out to me if you need help. Let's crush this. Work on those prime factorizations. Remembering you're canceling things out. You're dividing on each side. Let me know if you need help.